Good morning, everyone. Thank you very much for joining our webinar. This is actually the 10th in our We Make series, a project funded by the Energy and Water Agency, led by the Malta Business Bureau in collaboration with the Malta Chamber. I'd like to inform you that this call is being recorded, as have all previous webinars. I'm handing over to Mr. Mark Bayada in a leadership role from the Malta Chamber of Commerce for an introduction. Thank you, Mark.
Thank you. So good morning, ladies and gentlemen. Welcome to the 10th webinar of our We Make series. It gives me a great pleasure to inform you that this project is financed by Energy and Water Agency and led by the Malta Business Bureau in collaboration with the Malta Chamber, of which I form part as the council and also as a board of management. Today, we gather here to highlight some of the exemplary practices employed by leading manufacturing companies and shed light on the untapped potential for the energy efficiency improvements across various domains. Throughout this event, we have the privilege of hearing from esteemed speakers who will share their experiences and success stories. We are honored to have with us Engineer Montabone from Mater Dei Hospital joining us to showcase the remarkable upgrades in their HVAC systems, an upgrade that holds significant relevance across diverse sectors. Additionally, we have Methode, Carlo Gavazzi and Abertex present to demonstrate the interventions that they have implemented in their factories with a special focus on lighting improvements. Before delving into the details, let us take a moment to reflect on the broader context. So, Malta has made a bold commitment to become a carbon neutral state by 2050. This commitment has paved the way for development of a comprehensive national strategy known as the Low Carbon Development Strategy. This strategy aims to reduce our carbon greenhouse emissions, foster a resilient and sustainable economy, and shape a future that thrives in a low-carbon paradigm. The low-carbon development strategy encompasses several key areas of focus, including energy efficiency, renewable energy, sustainable transport, waste management, and land use. It sets specific targets for each of these areas, such as increasing the share of renewable energy in our electricity mix to 50% by 2030, which is quite challenging, reducing primary energy consumption by 40% by 2030, and slashing GHG emissions in the transport sector by 30%. Very ambitious milestones, but hopefully at least we have a target objective. Additionally, the strategy emphasizes the importance of promoting public awareness and supporting the development of low-carbon businesses industry. Today, by bridging the gap between theory and practice through compelling case studies and personalized approaches, we aim to inspire tangible action. We firmly believe that sharing practical insights and experiences will empower each one of you to embark on your own journey towards sustainability. I would also like to take this opportunity to highlight the valuable sustainability advisory services offered through the Malta Chamber's participation in the Enterprise Europe network. These services provide a high-level overview of the steps your organization can take to become more sustainable. If you are interested, please do not hesitate to reach out to us and we will be happy to provide you with the necessary contact details. Furthermore, our We Make project has previously highlighted various grants and funding opportunities available to support your sustainability initiatives. If you have any concepts or projects you wish to implement, please feel free to contact our We Make team for further information also. Empirical evidence has demonstrated that energy audits in small and medium-sized enterprises, refer to SMEs, can significantly assist in implementing energy efficiency measures. The impact is further enhanced when external finance is available and effective communication is established between the audit engineer and the company. Therefore, we highly recommend that SMEs who have not conducted energy audits in the recent years take advantage of this Energy and Water Agency grant, which covers 5,000 euros of audit cost for manufacturing companies. Apart from identifying and prioritizing opportunities for improving energy performance and reducing waste, the audit can also facilitate easier access to funding, as the auditor will lay the groundwork for you. When it comes to financing your green transition, it is worth noting that both APS, until now, both APS and BOV, through the European Investment Bank, offer 0% interest green loans. These loans are available for drawdown until the end of this year, so one has to really focus on accelerating and expediting on this matter. Additionally, many local banks are increasingly providing preferential rates or discounts for green investments. So I encourage you to engage with your local banks to discuss your individual requirements and explore the available opportunities. Finally, I would like to emphasize the importance of collaboration in propelling Malta's manufacturing industry forward by fostering innovative partnerships and facilitating the shares of best practices and knowledge transfer. We can overcome barriers, unlock new opportunities, and ensure the sustainable growth of our industry. Once again, I thank you for joining us today and hope this webinar provides to be a catalyst for positive change in our pursuit of a greener, more sustainable future. Thank you very much.
Thank you, Mr. Bayada, Vice President at the Malta Chamber of Commerce. We now hand over to Methode, Engineer Luis Montebello, and Engineer Joseph Lia.
Thanks, Timothy. Joseph will be presenting from our side.
Very good. We can see the presentation.
Okay. One second, because I'm working on two screens and...
No problem, Mr. Lia.
It's when technology is hindering you rather than helping you. Okay, so good morning. I'm Joseph Lia, Head of Maintenance. In the first part, I'm going to introduce Noel Briffa, who is from the Environment Department of our company. He's going to give you a very brief of what Metals does as a company, and then I will continue with the presentation explaining the energy initiatives that we have implemented throughout the years at Methode Electronics. Noel?
So, good morning to all. So basically, most of you are obviously aware of what Methode is, but for those who have perhaps little knowledge, basically, our core business is we produce electrical products for the automotive industry, namely switches, hidden switches, driver-operated switches, bus bars nowadays as well for electric vehicles, so on and so forth. There are other industries that we service, like railway to some extent, as well as industrial, so being it white goods, when it comes to electronic components related to them. That's basically it. I mean, as you know, we're located in Imriħel. I hand it over to you.
Thanks, Noel, for the introduction. During this presentation, I'm going to focus on the energy saving that we have done, mainly the replacement of lighting to LED. I'm going to tell you about the replacement of the production chillers that we have carried out in the previous months, the replacement of old production equipment, the energy saving on air condition, the smart air system that we introduced on the main compressor rooms, and the air leaks audit. Starting from lighting, during the last 10 years, we have replaced all lighting, and we are now working all LED lighting. Basically, the fluorescent tubes were replaced to LED panels. The metal halides have been replaced to LED high bays. We have done this by replacing these lighting. We calculate that we have made more than 600,000 kilowatt savings per year. Basically, during the replacement, we calculate that there is roughly around 50%, especially when replacing from metal halide to LED high base. Also, recently we have seen that the production chillers have been quite old. They have been running for a number of years, and although they were still running, they were not energy saving compared with the chillers inside the market. By replacing the chillers alone, we calculated that we're going to do a saving of around 160,000 units per chiller per year. We have 4 chillers in total, and basically it's quite a significant saving. We have compared the EER. If we see the old chillers, basically they had a cooling capacity of 236 kilowatts with an EER of 2.37. The new chillers, they have a cooling capacity of 310 kilowatts and an EER of 3.15. Apart from that saving, the old chillers had one evaporators, and therefore the saving that we're going to achieve is much, much higher than that we are showing over there. Another point, we are in continuous doing audits internally and seeing equipment that is old and mainly that consumes a lot of energy. One example is this oven. On the left-hand side, we can see a blue oven that we have been using for a number of years to carry, to melt. It's part of the production equipment inside one of the areas. When we did an energy audit, we noted that this equipment has a lot of leaks, is very inefficient, is quite large to our need. And therefore, after this study, we decided to replace it and buy a new equipment that is shown on the right-hand side. The previous equipment used to, we estimate that we used to consume around 150,000 kilowatt hours. And with the new equipment, we managed to reduce that to 35,000 kilowatt hours. This is only one example. We have in continuous checking about injection machines, about production equipment. And when we see a number of, when we see that there is a chance that while the numbers make sense, we proceed with replacement, even though the equipment might still be working. Air conditioning. As you know, Methode is quite a large company, has a number of AC units. Basically, we calculate that we have more than 350 units installed in our company. And one of the improvements we did is to employ 2 persons to take care of the cleaning of the filters and the cleaning of the AC units. By keeping the AC systems, the indoor unit and the outdoor units clean, we calculate that we see a saving between 5 to 15%. It's difficult to calculate exactly, but if annually we calculate that we are seeing around 65,000 kilowatt hours once we implemented this task. Apart from the hygiene of keeping the AC systems clean, we are also seeing energy saving. Also, during the winter period, especially, we are controlling on the use of AC units. Example, if we have AC units in the electrical switch room or the electrical hub rooms or the hub rooms, we try to switch them off, and because the temperature is quite good during those periods. And there are also some areas where we control the use and switch off some compressors of the AC units to maintain. Although we maintain a decent temperature, we avoid the waste when it comes to AC units. By this, we calculate that we do roughly an annual saving of 150,000 kilowatt hours. Another system that we have implemented that we saw quite a good saving was a smart air system for the compressors. Basically, we have a number of compressors installed at our company, around 8 compressors. And previously, before installing the system, each compressor was working individually. Basically, if we see on the left-hand side, the compressor was entering, reaching the maximum capacity of around 8 bar, and then running freely until it switches off or continues pumping air. By introducing this smart air system, this equipment controls the compressors and just tests the compressor on off, and therefore we are avoiding the compressor running freely and wasting energy, and finally the money we are paying in electricity bills. With this, with the system, we calculate that we have seen a saving of around 100,000 kilowatt per year per compressor, which is quite significant for us. With the system, we see the left-hand graph. This is showing the current on each phase versus time. During low periods, the compressor is running freely, and on the right-hand side, during those periods, the compressor is switched off completely, generating zero current, and is only working when required. Another system that energy saving that we work a lot on is air leaks. As a large company as ours, air leaks are a continuous war for us. We calculate that we lost around 100,000 euro per year on air leaks. On the table, I am showing the kilowatt each air leak cost our company, basically. And to solve this, we continuously carry out preventive maintenance on equipment, especially during the low periods and weekends and when the production is low. So we detect more air leaks. We also do air leak audit using ultrasonic testing equipment, and we are in the process of carrying an air leak audit using an acoustic camera. And basically, what we do is, this is a continuous exercise, and once we detect an air leak, we do our best to solve it in the least time possible. So we have avoid the waste of energy. That's it from our side. Thanks for listening.
Thank you very much, Engineer Liam. We've already got an excellent question for you, but we'll save the questions for the end. So in the meanwhile, let's move on to our next speaker, Roger Gallia from Carlo Gavazzi.
Hi, everybody. So thank you, Tim. I'm sharing my screen first.
Thanks, Roger. We can see it.
Okay, off we go. So yes, Carlo Gavazzi is mainly engaged in the development and production of power switches for the industrial and commercial sector. Let's say that our industry as such is not really a very high energy intensive from a manufacturing point of view. As yet, you know, energy consumption is relevant to anyone, you know. Through this presentation, we want to introduce some of the measures we have taken and connect them as well to our products, because in reality, our power control switches are very much connected to the theme of energy improvements, efficiency improvement. So first of all, we have conducted an audit way back in 2019, which clearly identified some areas and helped us, as Mark mentioned earlier, prioritize where we can make better utilization and conservation of energy. So an action plan was set up to implement such actions and investments, of course, where we starting up with the ones which will give us better benefit first. So here I am listing down a bit mainly the actions which came out and which were implemented so far. I don't want to repeat the things which were said prior with my colleague. I would like to start by saying, however, that the first important thing to start from is actually creating an employee awareness. It's very important that this is not the project of the plant manager. This is not the project of the general manager. It has to become the project of the company. And therefore, it is very important that all people who are participating in the manufacturing and the whole process are actually much more aware of what they can do as well through their own single contribution. And I think this is something which is something ongoing, and it is very important that you keep on stressing, especially also with new people coming in. I would like to mention a few of the points which I have here, which are not maybe highlighted from my previous colleague. First of all, it is that, of course, it is very important that you install meters. So metering is essential to help you understand where are the problems. So the first step after the audit was actually installation of different meters in different areas to help us discriminate the units where they are going. And that will clearly help you understand where to focus. Yes, we have also changed the compressor, we have changed the ACs, we have changed the lighting. We have also installed UV since our offices are facing south. So it was quite a big change to have these UV film installed on our windows. One important thing which we did as well was the replacement of test loads. So our product, we are in the power switching, and therefore testing our product means running high currents. So we have to test at 100 amps. And I think very important step we are looking, and I would say still ongoing, is that of replacing loads from active to regenerative. In this way, the energy is fed back into the grid, which is something which, of course, except for some conversion losses, which you always have in electronics, you are at least not wasting up the energy which is coming up. More and more, I would say we have been trying to use our own product and integrate them in our own equipment, as I will be sharing later on. One important thing as well to mention was this change, so we are using a lot of soldering, and we have changed all our systems from resistive to piezoelectric to induction heating, there's also a nice saving over there. So in the next slide, basically, I'm showing a graph which shows the results of this activity. So the orange is representing the number of pieces we produced, units produced over the years. As you see, in the last year, we made a very nice growth, following, of course, the pandemic area where we had a bit of a slowdown. The graph is showing as well, the blue line is showing the actual consumption of energy in kilowatt hours, the total consumption, okay? So as you see, it was very much following before let's say the unit produced. But as we increase the volume, the increase in the energy consumed is much less. And this is basically this is the important figure, which is the units per piece produced. So basically, in the last 4 years, since we started the audit and started putting the action plan in place, we managed to reduce the direct energy use per product produced from 1.67 kilowatt hour to 0.96 kilowatt hour, which represents a very important saving of an improvement of 42.5% in direct energy consumption. And this is something that the challenge, of course, is I would say is to sustain this, because as you can imagine, there were many opportunities which were carried over also by simply replacing equipment which we had. And this basically connects me to the subject that if we reflect where we have made the saving, it is mostly coming from the motors, you know, and maybe this is something I would like to stress to the audience, because good to know that 50%, okay, 50% of the electricity consumption in Europe is actually coming from motors, okay? So it is very, very, very important that the management of energy related to motors is of paramount importance, you know. This pie chart here is showing how motors are actually split up in terms of the market. So we are starting mostly from asynchronous motors, moving more into higher efficiency synchronous and DC motors. Okay, so I made a small mistake over there. Sorry. Okay, so actually we have the regulations who are helping us to do this. So good to know that as we see from the regulations coming from Europe and the IEC, etc., there is a clear requirement for users of motors to change their motor to higher efficiency motors. So when we speak about these numbers here, IE3, IE2, etc., these are the categories of the motors which in terms of efficiency. So I don't know, maybe the audience is not necessarily all technical, but these graphs explain quite clearly what I mean. So the graphs is showing the efficiency of different motors, category of motors. So these are different motor categories, okay? And these are the efficiencies, okay? Okay, the efficiency again, and this is the power. And what I want to show from this curve here is that you get double-digit gains by moving from an efficiency of a motor to another one, okay? And this is where the whole gain of stands upon, that moving to higher efficiency motors, as well as using speed controllers so that you don't necessarily run the motor at full speed when it can run at a different speed, you know? And this is something that, of course, is another aspect which we will mention later in my presentation. So yes, regulations are helping us and are a catalyst to this change, and we are in a way pushed to do it together to achieve the same objective. Important to say that such motors, new efficiency motors, however, tend to have what we call a higher inrush current, okay? So this graph I'm showing here is showing, this is the nominal current that a motor is usually taken. And this is the initial current when you are starting it direct online, okay? So one of the measures we have taken very much in our, because we changed the motors to high efficiency motors, is to more and more deploy the soft starters we have in our portfolio, which help basically to achieve this type of transformation, you know? So with a soft starter, we managed to obtain a reduction of 70% in the initial current. So as you see, this is the nominal current of the motor, and this is the initial current. And this is something that we deployed in our own equipment. So Carlo Gavazzi has a wide range of soft starters now, which is very much conversant with the new high efficiency motors, who can be deployed in such environment for higher efficiency solutions. Now I would like to pass the presentation to my colleague Brian Gauci, who is our international product manager for motor controllers.
Good morning, everyone. Thank you, Roger. So, linking with what Mark Bayada started, he mentioned the net zero. So, an important target when you look into the net zero are the heat pumps. Okay, so now from the ECO directive from September 2017, manufacturers of heat pump are enforced to not only show the coefficient of performance, but the seasonal coefficient of performance, you know, because if we take Europe, for example, we have different performance because of the different climate we have. So now they are enforced to change how they show the labeling, like we have on our fridges, microwaves, etc. And to achieve a good rating in this new system of labeling, they need to change to a synchronous motor. So Roger mentioned the asynchronous and synchronous, to go for a permanent magnet motor. Okay, so heat pump is continuing to be a very, very important appliance, and will continue to be a very important appliance, because the targets, if you look at the net zero, if we take a look, so currently we are taking globally, we are around 200 million heat pump installations. That results to a 7% heating demand. The target to the 2030 is to have 600 million heat pumps installed, which reflect to a 20% heating demand. And the target goes on until 2050, where there is a target of 1.8 billion installation globally, which that only reflects to just half of the heating requirements. So why is a heat pump so important, the carbonization, net zero? Because it is considered as a renewable source. So if we take a normal situation, let's take an air to water heat pump where the air is an input where it converts the energy. For example, we have 1 kilowatt input from electrical, and it gets also the majority of the energy from water, from air, and hence we have a 4 kilowatt. So this scenario explains we have a 4 rating of COP, because from 1 input kilowatt we have 4 kilowatt output. A heat pump can be a total renewable source because the 1 kilowatt electrical power, if it came from like, for example, solar, then it's total renewable solution. So that's why heat pump is more and more being very common, and many governments also in Europe are helping people to buy and subsidize heat pumps. So this is a very important topic in Europe at the moment as well. Now, with regards Carlo Gavazzi, Roger, you can. So as Carlo Gavazzi, we already have drives portfolio for this solution. But at the moment, there are many regulations changing. For example, the type of refrigerant being used in the heat pumps. And we are studying, so we are, as Carlo Gavazzi, going to the manufacturers, especially in Europe, to understand what is changing, how we need to evolve in drives. And so Carlo Gavazzi will continue to provide solutions for energy efficiency. Thank you very much.
So basically, as you see, we have basically gone through a journey where we were also very much also using our own product in our plant. And this has already given us quite a good, significant, improvement in our energy efficiency. Of course, the strive now is to sustain this and further improve upon it. And I think the last message from our side is that, yes, even though we are not a very high energy intensive manufacturing company, we can definitely say that it was so far worth the effort. So we have even pleased the finance people, and I think this is very important within the context of our forum here today. Thank you.
Thank you. That was a fascinating presentation, especially, for example, the bit about the role motors play in the overall energy demand of Europe. Thank you very much for taking us through that. It was
Thank you.
A set of very unique insights. So let's move on to our next speaker now. That will be Avitex, Neville Azzopardi. Let's make sure he's okay. Yes, thanks, Neville.
So are you seeing the screen? Is everything okay?
No, not yet. Not yet.
Okay, just a moment.
Okay, we can see. Thanks, Neville.
Okay. Okay, so good morning. I'm Neville Azzopardi. I've been working with Avitex for the last 14 years now, taking care of the plant facilities, also in a bit of activities in R&D. For those that do not know Avitex, we are mainly providing battery accessories for both the automotive and logistics sector. So for this we have plastic and rubber injection, automation, tooling, and also our electronics production plants in Mosta, because we have two locations, one in Cording, which is mainly plastics, and another plant in Mosta, which is mainly the electronics. So today I will present one of our energy efficient measures, which was changing the lighting of our factories from fluorescent tubes to LEDs. So as we all know, LEDs bring much higher efficiency when compared to other lighting technologies, such as halogen or fluorescent lights. But apart from that, something which is not mentioned is the longer lifetime of LEDs, and this contributes a lot in less maintenance. I remember when we had fluorescent tubes in the factory, every month we used to replace a number of fluorescent tubes, whilst when we installed the LEDs, this is no longer necessary because they are more reliable. Apart from that, if one takes a good design approach, you would also achieve better lighting and a better environment for all the workers in the factory. So first of all, to start a good design, you have to consider which type of LED lighting is best for your application. For offices, for example, we would usually go to panel LEDs or LED profiles, while in large areas, one would choose high power LEDs. Of course, we have to check standards. There are many standards for every activity and type of room in the production area, where there you require different lux levels, different color temperatures and color rendering and so on. The first step is to simulate the LED setup in software. There are softwares available today that help you simulate the position of the lights, the intensity, the power needed, to see beforehand what lux levels you will achieve in your area. One important factor is to try and distribute the lights as evenly as you can in your area to make it more pleasant to the eye, and also reduce glare from high power, especially LED light fittings. Here we can see some screenshots of some simulations we've done. On the left, it's a simulation we've done for the injection area, where we see high spots of light intensity where some inspection activity has to be done, and then the lower light intensity is just an area where passageways and so on. This helps you achieve also your best efficiency in the lighting. So you're not just achieving efficiency by replacing it to LED, but also by optimizing your lighting setup. On the right-hand side, we also are showing lights rendering, which we can do with our software. This is a render of our storage area, where we have done some simulations to make sure, since the light fittings are very close to the higher shelves, that the higher shelves are also lighted up with enough light. So after achieving efficiency by replacing to LED, another step is to make it smart. One can install presence or lux level sensors, dimming features, and control everything via BMS to control as much as possible and reduce the consumption on the lighting system. Another setup we've done for our offices is connected to a battery system and a PV system. This has got the lighting system completely off-grid, making it completely renewable and also more reliable, because if there are any grid cuts, you will still can keep on going with lighting system through the battery. This also has its advantages, and still can be connected to the grid for backup if there is a lot of bad weather. It runs on a low voltage, so it can be done in small areas, unfortunately, but it's very reliable because we remove all the conversion power electronics, because we are working directly with low voltage from the battery to the LEDs. Here are some examples of our installations. Some LED light fittings which we installed in our meeting room. As you can see, we've done custom-made LED light tubes for our area to have as much light intensity throughout the room. Here is another example. You see it dark because for the photo effect to come show the lighting. I'll show you also some pictures from our production area. This is our tool shop. Here we've done also continuous lighting tube to have very good light distribution throughout the area. But then we also included some high bay units where inspection work needed to be done in order to achieve higher levels of lights for that area only. This is our electronics production. As you can see, the light is even throughout and very pleasant to be in and very comfortable. All this could be achieved through the homework done before in the simulation software and design. Hope my presentation was interesting, and thank you for your participation.
Neville, thank you very much. It was extremely interesting, actually, because I think a lot of people underestimate the complexity around lighting and the connections you've drawn, for example, with the software, the modeling it and simulating it, the link to the building management systems was actually very, very, very interesting. So thank you. That was very educational for me as well.
Thank you.
Let's move on to Engineer Ramon Tabone from Mater Dei.
Good morning.
Good morning.
I'm trying to share the presentation. Okay. So, good morning. I'm Ramon Tabone. I'm the Senior Mechanical Engineer at Mater Dei Hospital. Today I'm going to talk about a project that we've been doing in the last years, and it's nearly at the end of implementation. Most of you, I don't know if you follow the news, but this initiative was awarded the best green initiative in the public service. So basically, start the presentation. Okay. So this is Mater Dei, as you see it from Google Maps. This whole building, we have Mater Dei Hospital. This is all Mater Dei Hospital, and this is the Oncology Center. Mater Dei Hospital, I mean, we all know what Mater Dei Hospital does, but a few people know the intensity of engineering involved in this building. Most probably is one of the single buildings that is energy intensive in the country. Just to give you an idea, maybe you can compare with your factories and installations. Mater Dei Hospital has a total installed capacity, electrical capacity of 18 MVA. We don't reach that figure, but I've seen figures in midsummer peaking at 12 MVA. And in winter, we go down to approximately 5.5 MVA, which you from this data that I'm giving you realize that most of the energy involved here comes from demand in air conditioning and ventilation. So this is the plan that we have. We have quantity 17 chillers of 1.2 megawatt cooling power each. We have 14 air-cooled chillers and 3 water-cooled chillers, 4 liquid fuel-fired boilers of 2 megawatts thermal output, 124 AHUs, air handling units, which are units that handle actually the ventilation, cooling and heating, and the humidification of the fresh air going into the hospital. Some may ask, why do we have so much separate air handling units? The reason is that in the clinical areas, we have 1 air handling unit for each separate ward. So the wards are separate from each other. That's why we end up with 124 AHUs. The figures that I'm giving now are approximate. We have approximately 2,000 fan coil units and 1,000 chill beams, and approximately 200 pumps, which cater for chilled water and hot water services. For the non-technical, fan coil units are equivalent to air conditioning units we have at home, but instead of receiving refrigerant, they receive chilled water and hot water from the central plant. Chilled beams are similar, but they are designed to operate a much higher temperature, we operate them above 16 degrees Celsius, so they do not condense the water from the air. And basically, chilled beams are used in the clinical areas. So what is today's subject about? This subject is being referred to in Europe as the electrification or decarbonization of heating. As I told you before, we originally used boilers to heat the hot water. We have hot water demand both to heat the water for showers and wash hand basins, but we use a lot of heat to heat the air, the incoming air in winter, and for the humidification purposes. For the non-technical, I'll explain this in brief. To dehumidify the air, you first cool the air excessively. What in HVAC we call, you go below the dew point. So you condense the water from the air, but then you cannot send the air into the wards and the rooms at that very low temperature because you'll get discomfort. So what we'll have to do, you have to reheat it again at a comfortable temperature. And that's where the heat demand comes from HVAC. Why use heat pumps instead of boilers? As we'll see in later slides, heat pumps have a higher effective heat output compared to the heat input you give them. What are other advantages? Heat pumps do not generate any pollutions on site. Boilers, we know that boilers, when you burn fuel on site, they generate carbon monoxide, nitrogen dioxide, and even particulate matter. So these are simplistic representations of heat pumps. Heat pumps in Europe are gaining ground even in domestic installations. Basically, we have two typical installations of heat pumps. On the left, we have the ground source heat pump, which is heat pump is basically a refrigeration unit, similar to an air conditioning unit. What we do is we give electricity to the heat pump. We take away the heat for our use, to heat the building, to heat hot water, and the cold side is dissipated into ground for the ground source heat pump. Why is this so common in Europe, and why do we dissipate this to ground? Unfortunately, in Europe, they have sub-zero temperatures. And this is something that's not very comfortable and not something that you want on the condenser side on the outside unit of an air conditioning. So why ground? I mean, we all know, I mean, that the ground tends to keep a constant temperature all year round. Some say that we keep the temperature of the ground approximately in winter and in summer at about 15 degrees or 12 degrees Celsius. So this gives you the opportunity of a stable operating mode for your heat pump when you do ground source heat pump. In Malta, we don't really, you can use ground source heat pump, but we don't have problems with very, very low temperatures in winter. So alternatively, you can use the air source, air-cooled heat pump. What we do here is, again, basically it's like you're using your air conditioner at home, you put it in heat mode. What you're doing here, you're taking away the heat to the building and dissipating the cold from the outside unit. But recently, we've been hearing as well that there are rebate schemes for investing in heat pumps, which operate on the same principle, but they heat your hot water at home. So, is the installation at Mater Dei a simple heat pump application? No, it is not, because as I said, traditional heat pumps usually they dissipate the heat to atmosphere or underground. While the installation we have in Mater Dei, we don't dissipate any heat, but we make use, we don't dissipate that heat or cold water, but we used both products of the electricity we put in. Why is this possible? As I said, being a hospital, we have still cooling needs in the winter months. Most of the plant rooms here, we have plant rooms and we have IT hub rooms that they have an internal heat load that's still present in winter. So still we have a good amount of cooling demand in winter as well. So we have a situation when we have a minimal cooling demand in winter, but we have a high demand of heating. And in summer, we have a high demand of cooling, but still we can have a high demand of heating because of the humidification purposes. As I said, no heat is dissipated to ground. This makes the system even more efficient than a regular heat pump. So basically, I have a comparison of both technologies here. These are the actual installations that we have here, the original boilers on the left. The figures for the boiler are taken from the data sheets. The figures for the chiller are taken from an actual test carried out at the Trane factory, which I did witness in France. So as you can see, energy, let's compare energy. So we are inputting into the boiler, we are inputting 2.2 megawatts of fuel. And even though, I mean, I have to say that these boilers are very efficient. They have at least an efficiency of 90%. I mean, you can get older boilers that they are not as efficient as these. But anyway, we're inputting 2.2 megawatts of heat, of fuel, and we're getting 1.98 megawatts in the hot water, going to the hot water. And that's an efficiency of 90% or 0.9. What happens in our water-cooled chillers? So we're giving 0.44 megawatts of electricity, and we're getting 1.2 megawatts of hot water. And at the same time, we're getting 0.72 megawatts of chilled water. So if you work out the heating efficiency ratio, we're getting 2.7 times as much, and cooling efficiency ratio 1.6 times as much. This makes the machine, the total efficiency of the machine, 4.3 times as much efficient. So some may say, I mean, not all establishments, not all buildings have a demand for both hot water and chilled water at the same time. Yet you can say that even, and I've seen this, I mean, heat pumps have been around in Malta, even on big installations, not as big as these, but I've seen heat pumps in hotels about 12 years ago. And basically they were operating the chiller in heating mode. They were getting the hot water, the heat, and dissipating the cold water. So even if you don't have a demand for both chilled and hot water, you're still running at an efficiency of 2.7 times as much. So it still pays off to operate a heat pump and not a boiler. Considering also the fact, as I said before, that you're not emitting any flue gases. So, as I said, we have 4 Wiesmann 2 megawatts hot water boilers. We have 5,000 liters of hot water buffer tanks. Basically, they are there to stabilize fluctuations in the system. And we have 3 Trane R2WF 370 HE water-cooled chillers. So something which I have to say is that the original installation Mater Dei already had a chiller with a heat recovery system. So what's the difference between the original system and the new implementation? The original system had a chiller, a water-cooled chiller, that operated as a normal chiller in chilling mode. So its purpose was to provide chilled water, but at the same time, its condenser side was connected to a heat exchanger to preheat the incoming hot water. Again, what's the critical difference between the old system and the new one? The old system had the chillers that can go up to only 50 degrees Celsius. So you know what's the problem here. You realize the problem. So we have to keep the domestic hot water here above 60 degrees Celsius for sanitary purposes. All the air handling units and fan coil units have been designed to operate at 60 degrees Celsius. So with 50 degrees, there's not much I can do. But what can I do with 50 degrees? With 50 degrees, I can preheat the incoming cold water before going to the boilers. So actually the old system, what it did was, I'm getting water at 23 degrees or maybe even 12 degrees in winter. It's coming in, it's exchanging heat with the condensing side of the chiller, which is about 46 or 48, and it's preheating the water. What's another disadvantage of the system? The other disadvantage of the system was that the load is intermittent, which means you don't have the cold water coming in continuously in the system, it's intermittent. So to stabilize the chiller, you had to have a dry coolers above, which is the ones here, the dry coolers, which when you don't have demand of hot water, the extra heat generated by the chiller goes and to dissipate into ambient. Otherwise, it will go on over temperature, over pressure, and the chiller will trip. So if you, as I said before, the old system, it dissipated heat to the atmosphere at some times. Still, from that 50 degrees and beyond, we had the boilers to heat the water up to the required temperature. This system, obviously because of the temperature, was not integrated on the HVAC for obvious reasons, as I said, because the temperature was low. So this is basically the description that I gave here. So what changed? What was the optimization? Basically, there was a change in design. When we, incidentally, way back in 2018, we were about to change all the chillers due to the end of life of the chillers. And basically, we were studying together with the contractor why. Basically, I had this question: why? How do your water chillers work, and why do you need water chillers? I remember way back in 2015, I was employed at Mater Dei Hospital in 2015. I was studying all my systems to try and optimize for energy efficiency. And I've seen that the amount of heat demand that we have on HVAC surpasses by far the demand that the domestic hot water imposes on the system. And I said, at the time, I was not aware that there are chillers in existence, that chillers of this size, I mean, talking about 1.2 megawatts, that can operate in heat pump mode and that go beyond 50 degrees. Basically, these chillers go up to 68 degrees Celsius. So I had to sit down, redesign the whole system, integrate the new chillers. So basically, we end up with this system. Now we have the chiller that can go up to 68 degrees, which means now I can heat all my hot water. I can supply all my hot water demand. That's enough for me. And I can still take care of my HVAC hot water demand as well. And first thing I installed, and I had this in mind to install energy meters. We have two physical type energy meters here that give me the instantaneous power output and the total accumulated energy recovered. So where does the boiler come in play now? Okay, with the installation as per se as now, still it does not cover all the heat demand that we have. So the boiler is just there to top up the remaining demand that we have. So this describes, as I described, all the system here at Mater Dei, all engineering services are connected to a centralized building management system. So I said I installed the digital heat meters, and that proved very important to collect data and compare. So basically, this is part of what we call the Trane Tracer chiller management system. This is only a part of it, which takes care of the hot water system. I have the water-cooled chillers here. At this point in time, the HVAC was recovering 0.72 megawatts. I have peaked here beyond 1 megawatt, 1.1 megawatt. Even this morning, it was giving out 1.1 megawatt of heat coming from the chiller. This is the part of the domestic hot water. Here I have peaked to 0.72 megawatts. Basically, all the demand for the domestic hot water is coming from the chiller. Here we have the heat exchangers and pumps that exchange heat with the boilers. Basically, they're on standby. If something happens to the chiller, they come in automatically. But I mean, all the heat demand on the domestic hot water is coming from the chillers. So I took the latest data for a whole year, which is 2022. As you can see, the dark green is the energy recovered for the domestic hot water. As I said, I mean, we're not using any fuel there for the domestic hot water because the demand is covered only by the heat recovery of the chillers. As you can see, something which I have anticipated in my original design in 2015, 2016, when I was studying the system, the demand on the hot water system for the HVAC is nearly twice as much the demand on the domestic hot water. This is something which we didn't have originally, and this is something which was, say, a turning point of how we consumed how we saved all that fuel consumption. These are the results down here. As you can see, we started implementing the system in 2009, but obviously in 2009, we didn't have a full year of data. So pre-2009, we used to consume 1.7 million liters of fuel, sometimes even 1.8. And that amounts to 4.6 million kilograms of CO2 emitted. Now we come to the savings for the last year in 2022, and these are savings actually. 1.1 million liters of fuel saved, which means that 1.1 million liters of fuel have been replaced by heat coming from the heat pumps. And that makes up to 3 million kilograms of CO2. Since the installation, in total, we have saved almost 4 million liters of fuel, and that amounts to 10 million kilograms of CO2 saved. So basically that comes to the end of the presentation. I don't know if we can pass to the questions, so there are other presentations, I know.
Thank you very, very much, Engineer Tabone. You stated before the call that the energy use of Mater Dei is equivalent to for example, Gozo? Or...
Yeah, I used to hear that a lot. I mean, Mater Dei, together with some other factories, big factories, is considered one of the most energy intensive buildings and one of the top consumers of energy as a single building in the country. I used to hear that a lot. That I don't know Gozo now. I mean, what's about Gozo now? But I used to hear that 18
Yes.
MVA was equivalent to the electrical installation of Gozo. I don't know if that has been surpassed in Gozo now, but I don't.
Yes, but in any case, it puts things into perspective, doesn't
Yes.
it? And you've given me an appreciation and understanding for the contribution of heat pumps, which I didn't have previously. I mean, I've heard a lot how the European Union is pushing the importance of heat pumps, and I think the projects you've excellently executed at Mater Dei show the huge potential there. So thank you very much.
Thanks.
It was a very fresh perspective and insight and case study. Now we're moving on to our final presentation of today. It's Abatex. I'm going to be sharing the slide for Maruska Bartolo. Over to you, Maruska.
Thank you. So I'm Maruska. I'm from Teva, previously known as Actavis. We're a pharmaceutical company. We have done a lot of projects because we started energy management projects in 2010. So we are 13 years down the line. So as you can appreciate, all the low-hanging fruits I have now achieved. So we are going through our existing systems and see how we can make them more efficient than we hope they already are. So we started off by replacing equipment, making sure that we get obviously the latest technologies, but also not like with like. So if we are replacing the humidifier, just don't go for the latest the technology, but we see whether we can even change the type of the humidifier we have, so we make the systems even more efficient. And two projects that we are working on are how to make the systems more efficient through maintenance is testing. So we have steam trap testing that was previously done using ultrasonic detection. However, ultrasonic has some disadvantages. One of it that you need to go close to the steam trap. I have to use leather, so it's not that safe. So we changed to a thermal imaging testing. It's more easy for interpretation. There is no room, or the room for interpretation is less prone for mistakes. And we get the same results. Similarly, for compressed air leak detection, again, we used to have pinpoint ultrasonic detection. Now we went for acoustic, which also was mentioned, if I'm not mistaken, by Metal. It's easier to do, and it captures a smaller leaks than we used to do before we had this type of testing. In both cases, they were a replacement, so they are not new testing, but having new technologies meant that we can use the equipment for different testing. For example, the thermal camera, we didn't bought it for steam trap testing, we bought it for electrical use, but once we had it on site, we can use it efficiently as much as possible. My presentation was very short, so any questions?
No problem, Maruska. Thank you. I think it's very important to have a case study like yours, which shows what's potentially still possible and what kind of procedures might be followed to identify energy savings opportunities once, as you said, the low-hanging fruits have already been taken up.
Thank you.
So I know we had a question earlier from Gabby. I think it's a question which can probably be answered by everyone, but we'll need to be very concise because we shouldn't get past 11:30.
Yeah. Hi, everyone. Thank you for your presentations. Very, very interesting. So one of the things that crossed my mind when you were all presenting is that obviously none of the processes and the equipment that you installed would have come at a cheap price. So I was wondering how, if you could share any information on how you financed your investments, if it's not confidential, of course, if you made use of any of the grants that are available, and also if you calculated the return on investment, the financial return on investment, because obviously there are the comfort aspects and there is employee satisfaction as well that comes into it. But in financial terms, is there sort of an average that you would go by to make your investment worth it? Or do you see it simply worth it because it's the right direction to move into? I don't know if anybody wants to answer those questions. Maybe it's not a very straightforward thing to answer, but just maybe if you have some insight, that would be great.
So from Methode point of view, from Methode side, basically we do not get any sponsorships or any money from any other source other than internal expenditure. So basically we propose a project, it is passed through our leadership committee, and if it's obviously accepted, we just implement. From an ROI point of view, we use a very standard accounting ROI methodology. Normally, when I present the what we call the CARs, the capital projects, if their ROI is within 2 years, there's a good chance that it will be accepted. So the 2 years is basically our limit case, but from the projects we have presented, where Joseph presented the projects, there were some that went up to 5 years, but still we managed to get approval for the investments. But all the investments are Methode investments, basically.
Okay, thank you.
Okay.
Here at Teva, we have similar approach. So again, we propose to our leadership team. Again, the return on investment accepted should be usually less than 3 years in our case.
Okay, quite a tight window. And just a quick question. So is this because Methode and Teva wouldn't be eligible for a grant, or it's not part of the internal strategy to apply for the schemes?
I'm not sure that we're eligible, given that we are not an SME. So till now, there wasn't a drive from our side to get funding. But it's not, I'm not saying it's something that we will not investigate in the future.
Okay, very interesting. Thank you, Engineer Montevello.
Same here. Never investigated going further.
Okay, that's very interesting to know, especially for the policymakers and for EVA present. Is Carlo Gavazzi still here? And Abatax?
Yes, we also have not used any funding. We have a very similar system as colleagues mentioned before. But I would stress that, yes, considering, you know, that the investment, that the payback of something which is anyway the direction we need to take, which is typically within the range of 2 to 3 years, I think this is in any way should be considered from a financial point of view a positive thing to do. You know, so you are going in the right direction, and you're not really, you know, it's not something that is paying off in 10 years, you know, or 8 years, you know. So I think yes, same here, that we are self-financing this activity.
Thank you, Mr. Galia.
Could I ask another question, please, Tim? Sorry.
Okay, I know Neville was going to answer the question.
Oh, yes. Okay,
Yeah.
sorry.
From our side, we have used funding both from Malta Enterprise and Energy and Water Agency. It was quite helpful, but in any case, our management pushes to invest in such projects to reduce our consumption anyway. But the help from the grants is also well accepted.
Thanks, Nabil.
If I may, Tim.
Yes.
I would like to invite Method, Carlo Gavazzi, those who haven't benefited from grants, because they could use them to reduce the ROI by kind of fitting in the grant, and thus, of course, reducing the financial load on the company. We're available if they would like to contact us, Malta Business Bureau, to facilitate the process for them.
Thanks, Gabby.
And they are applicable also for non-SMEs?
Yes, there are grants which are available for large companies. Yes.
Okay. Okay. Thank you.
Yes, even digitalization grants, which can be used for energy monitoring software, for example. But yes, very interesting to realize that there wasn't so much awareness amongst non-SMEs about the financing opportunities. So that will be a good follow-up for us. Okay. I know that one member of the audience was also curious about Abatax's batteries, in particular, potentially applied to boats. Does that ring a bell, Neville?
Yes, we also offer such a service. Currently, the marine sector is quite an interesting sector for us because it's also getting electrified. And we also provide batteries for such applications, yes.
Okay, very interesting. That could be a potential future topic to explore.
Yes.
Okay, I think that brings us to the end, especially since we don't want to go over 1.5 hours. However, thank you to all the speakers for your excellent and varied presentations. I personally learned a lot today. This, as I said, was the 10th event of our We Make series. We'll have another one next month on industry academia collaboration, and then a final one which we will discuss the topic of still for July. It's been excellent having you all. I'm going to be putting up the recording online as well, and I'll be sharing it with everyone in attendance. Thank you and have a good day and a great week.
Thank you, same to you.
Thanks.
Bye. Thank you.
Thank you.
Yeah.